So today we're going to look at a technique for combining mesh with a dynamic hair to create something like this. So this was from an animation uh, where somebody is making the translation of a polypeptide chain from a ribosome and wanted to make the growing thing more dynamic. It actually also looks like a goldfish pooing a little bit, long strand coming out and being sort of caught up in deformations here. So the easiest way I think to do something like this is to use a dynamic hair and to animate a mesh system along it. So here we can see it in Maya, and so we'll just look at the components and then I'll rebuild it. So it's playing back a little bit slowly, but if I just stop it here, I'll switch to my perspective camera. So here's the original curve that I made dynamic, and this is the output curve from the dynamic system. And then I just have a torus down here. And then these are the mesh objects that are being animated along a curve node using the offset along curve function here. The dynamic curve, we can see here, what we'll ultimately create is an original curve that's attached to the follicle, and then a dynamic curve that is calculated based on the hair system and within the parameters set by the nucleus node. And then the floor here is just it's actually a collision object in case the turbulence on the hair were to push it down to the ground. The torus is also a collision object for the same reason. And if we look at the curve here to make it feel like it's colliding with itself around the same diameter as the spheres that are attached to it through the mesh system, if we go into the hair system shape under collisions, let me just change this to so we can see this is the self-collision thickness being demonstrated here. I think this is supposed to, yeah. If I put it to edge, it's a little more clear. And so this is the collision thickness of that curve. And we can alter this in the nucleus node in the hair system shape here. So we'll get back to this in a minute. We'll just recreate this from scratch. So let me save this. Save this as hair demo. Okay, so let's just do this quickly. I'll just do the basic parts of this, which is building the curve. And so I'm starting with already not a dynamic, but a somewhat complex shape. This is the path that the mesh objects are going to move along. So I'll just make something quick like this, and then in the perspective view, just go into, if I hit B, I can go into soft select mode, and if I just double click here, we can see on the move tool settings under soft selection, I've got it set to surface rather than volume, because volume will select in a volume around the one vertex you have selected. Surface will select along the curve this way, which is more of what I want. So I'm just going to adjust the shape a little bit just so it's a little more complex when we get started. Okay, and I'm just going to keep saving as I go because this could be a little bit crashy. So if I select this curve now, I'm going to freeze its transformations and delete its history. And then I will turn it into a dynamic object. So under the effects menu, nHair, make selected curves dynamic. NURBS curve, that's all we really need selected here. And now we'll see the things that are created. So a hair system is created, and that controls the dynamic attributes of the hairs within this system. there's a nucleus node which controls the sort of environmental variables of the physical world that's being simulated here. And then we have hair system 1 follicles, and this holds the original curve. And then under hair system 1 output curves, that's the dynamic curve. So that's important to note because this curve is the one that we're going to attach the mesh object to. So I'm just going to rename it to dynamic curve just so it's a little more obvious. And then maybe I'll call this one orig curve. Okay, and then some settings that we need to change are here in the follicle. If we click on it here. So the important thing right here is the point lock. So the dynamic curve is exactly overlaying the original curve right now, and it's locked at both ends. So if I were to play the animation, and I'm just going to give myself some more frames to work with here. If I play the animation, we'll see that it falls down due to gravity because there's gravity by default in the nucleus node, but you can see it's point locked to the original curve at the beginning and the end. So if we go into the follicle shape, point lock both ends, change this so it's only locked at the base. And then it can fall freely and it's still locked here at the base. Right? Okay, so good so far. Save. So now I want to turn off gravity, but I'll just turn it off for this hair system. So if I go into the hair system shape here under dynamic properties, I can just turn off or turn on ignore solver gravity. So now when I play the animation, nothing will happen because there's no force acting on this curve. But unlike other nHair or N objects, the nHair has a built-in field, Turbulence. Again, we're in the hair system shape, and I can just turn this up, and then we'll see that that turbulence will serve to animate this thing moving around. Okay, so that can be pretty good. If we want to control how sort of floppy it is along its length, we can use the attraction scale here. So if we turn up start curve attract, it does what you would imagine. It makes the dynamic curve attract to the start curve. So now you can see that it's not really able to escape from the start curve as I have this set to 1. But there's also the attraction scale here. And this means that at the beginning of the curve, if I just pop this open, at the beginning of this curve, which is at its base down here, it's fully attracted to the start curve. And then it goes down to, you know, like 30%, 25% or something. So we could do something like this. And now that allows this end to be kind of floppy, but you can see here it's sticking to the original shape. So this can be a good way to help it avoid crashing into something nearby. So you can use this if it seems useful. I'm actually just going to turn down my turbulence a little bit here. So that is in the hair system, turbulence. Yeah. So just because there is a turbulence built into the hair system shape doesn't mean you can't use other fields on the hair. I never know what to select here, but I think I select the hair curve. And then if I go to fields and solvers, I'm going to apply an air field to this. I'm going to use a wind, and I can change this after the fact, but the direction I want it to be pointing in is Y. So it's blowing up in the scene. So I just want to use this to kind of straighten out my curve over time. Okay, yep, so I got the normal error. I probably had to have something else selected. So it says I didn't have anything correct selected to do this. So I can fix that because the air field was actually created. So if I go into Windows Relationship Editor, Dynamic Relationships, and if I go into the hair system, so I guess I had to have the hair system selected, and I can just highlight airfield. Now it will listen to the airfield. That airfield is down here in the middle of the world. So you can see the little propeller. And it's pointing up in the world, but if we look in here can see it's got a magnitude of 1, and it's got a 5, and it's got an attenuation of 1. So that will fall off in strength over 1 unit. So I'm going to turn that to 0 just to keep it consistent with no fall off. So now you can see it's blowing the thing up. So whether I want that or not, I don't know, but maybe I do. Let's pretend that I do for now. So now I want to animate a sphere going along the curve. So I'll just create a cube, shift right click, smooth once. Okay, that's weird. I think I did the wrong kind. Shift right click, smooth. Okay, that's better. So I just have a sphere here. So just smooth cube, so you have a non-polar sphere. I just hit 3 on the keyboard to make it smooth. So now I'm going to turn this into a mesh, create a mesh network. This can be an instancer to reduce the load on the machine. I'll just use linear for now, but I'll change that soon. So have what we would expect. So in the mesh node, we want to add a curve node here. And then the curve that we want to add is dynamic curve. So I can just add that. And now you can see it's sort of linear, but with the curve node too. So we just have to go back into distribute and make sure our distribution type, which is linear, just make sure that the distance x is set to 0. And now you can see that in the curve node, it's controlling this. So if we play the animation, it's moving along the curve, and it's moving along the dynamic one, which is what I want. Okay, so now if I change a few things here, I can change the steps. So if this goes all the way up to 1, this is in the curve node, then it's filling the entire curve with as many points as we have in the distribution. So I can turn up the distribution points to something so it's filling up the whole thing. So I've got mine set to 100. And if I play the animation now, you can see it's just cycling through the animation. I don't want it to keep going when it gets to the end, so I'll go into mesh curve and say stop curve at end, stop at curve end. So it's continuing to go here, but it's not refilling at the base. So I just want to turn animation speed down to 0. So now it's filling the whole thing, and it's just attached to the dynamic curve. But I do want it to grow, so a different way of doing this is to use offset along curve. So I'm going to start at a negative value, so -1. So there are none of them here, or there's 1. Yeah, so that is along the curve. So I wonder if we go to mesh curve, if we do -0.1. No, okay. So I guess I didn't see it before because it was hidden by my torus. So if something's not working, just hide it. So then I want to set a key here at my first frame, and then let's say over like 150 frames, it goes to 0. Key that. And anything that's keyed, I can go into the graph editor, and I've got a nice ease in and ease out here. Just going to turn off view infinity. Ease in and ease out. So this is probably what I want. I don't want it to be linear. I want it to ease out and then ease into its position. Now if I want to make it look more like stop motion or something, I guess I could kind of make it stepped or take it into After Effects and use a posterized time on it, something like that. It's probably be easier to do that. So now let's just take a look. It's going to be a little slow. No, it's not too bad. Okay, so you can see it's growing along here, following this dynamic curve, and so on. So I think my air field's too strong. None of this matters. I'm just doing this kind of for fun now. But if I I could make it some attenuation. Like I could have it fall off over, like 20 units or something. Let's see what that does. So it is working. You can see it's not nearly as strong, the airfield. And, I might want to turn up my turbulence a little bit. So the good thing about all this is the only thing you really have to animate, set keys on, is that offset curve. But we can, what am I looking for? Oh yeah. But we can go in and change the dynamic properties at any time to see different effects. So I turned up the turbulence. I turned up the turbulence frequency to get a different sort of look. Now it's hard to see unless you play blast this, but you can see it's following an interesting path. Now one thing I want to avoid is to have it passing through itself, right? So that's not happening right now, but I can try and guard against that by going into the hair system and going under collisions here. So by default, self collide is turned off. So we want to turn self collide on. This will probably slow it down a bit. No, it's still pretty good. So this is the hair self colliding with itself. Self colliding. And so here's a point where it's almost going to collide. Now let's see what happens. Right, so that's what we want to avoid. We don't want these spheres to go through each other. Now we can't make I guess we could make the spheres dynamic, but I think that would result in disaster. So instead, we're going to make the curve dynamic, make the curve self-colliding. And I'm going to change the thickness of that simulated collision. So to see what I'm talking about here, under the hair system, under solver display, we can turn on self-collision thickness, and you can see it's just this yellow line here. So if we say collide width offset, change that to 1. Okay. Let's go back to 0. So you see, you have to advance or change the frame to see the effects of this. So I'll just put this to 1. And then I'll set the self-collide width scale to something like 0.5. So we just want it to be about the same thickness as one of those spheres. So let me just play this with this on. See if we get close to a collision anywhere. Yeah, right here. So it's using this thickness to avoid colliding with itself. And as long as it's close enough, it'll do a pretty good job. And so you can see if I wanted a more refined, so it's doing a pretty good job there. Self-collision, I'd need more points in my curve and things like that, but this is fine. So I can just turn that off so we don't have to see it. But here you can see it's preventing these from going through each other. Remember, whenever you're doing this kind of stuff in your timeline, right-click, playback speed, choose one of these play every frame options. I've got mine to play every frame max real time. It's not getting close to real time right now. If you want to see its frames per second, we can go to display, heads-up display, and turn on FPS, frame rate. So if I go back and play, it's at 0.6, a little hard to see down there. So I'm only getting about 4 frames per second right now. Okay, so that's about it. The last thing I'll say is that you probably want to cache this, and you can cache this in a couple of ways. One way is to, you could cache the hair, right? So select the hair system and go to nCache, create a new cache for an N object. Another way to do it, though, is to actually cache the mesh, and so I'll just do that. So if I select my mesh distribute, no, my mesh wader node, and there's a caching option down here. The only thing I need to cache is the position of each of these spheres. So I'll just click on that and I'll open the cache editor, or creator, sorry. And I want to make sure that that is selected, start, end. So I'll just cache, I don't know, 200 frames. And just click create cache. And it will run through those 200 frames, and we'll have to sit here and look at this. And the reason for caching something is really just so it's more predictable when you go to render, particularly if you render on more than one machine. So if you have a couple of workstations and you're rendering part of the animation with one machine and rendering the rest of the animation with another, as long as they can find the same cache in your project, then you know that the animation in both versions will be exactly the same, and you'll get the same results. So you could go from frame 199 in one to frame 200 in rendered from a different machine, and you know that they will match up. So now that I've done that, I'm just going to reduce the number of visible frames to 200. So I should be able to scrub through this because the mesh is cached. You can see that there is a cache folder linked here. There's a new cache node, and you can disable this if you want. You can also select it and delete it. But the hair is actually still being calculated. We don't really need that anymore. So one way to stop the hair from calculating is you can go into nucleus here, and you could just disable it. And so it won't calculate the hair anymore. You could also go into modify, evaluate nodes, and turn off all nucleuses. You can see it turned off that nucleus for me. It's the only one in the scene. But if you had more than one, then that's a way of doing that. So now it doesn't have to calculate any of those things anymore. You could turn off the airfield and all that sort of stuff, and it should, well, it's playing back at about the same speed, but it doesn't have to calculate all those things. So now you can't even see the hair is not being calculated, so the dynamic curve is not moving. But since we cached the mesh position, it's following the curve at the time of caching. If you want to go back and turn those nucleus evaluations back on, it's a bit buggy. If you go to modify, evaluate nodes, and turn nucleuses on, that might work. And it did seem to. But if it doesn't seem to be working, just go in and go to evaluate nodes and evaluate all, and that will force them all to work. So now if we go, now you can see that that curve is moving again. So there you go. That's how you can use a dynamic curve with a mesh system to make this goldfish pooing sort of animation. Thanks.